Hi. Sorry, can you see my screen?
Yeah, I can see it now. That's fine, thanks.
Yep. Hello, I'm Sam, and I am a geospatial analysis student at UCL. In partnership with Movement Strategies, I have developed a master's project titled An Assessment of the Impact of Weather upon Shipping Patterns using AIS Data and Weather APIs. So the global shipping network forms the backbone of the globalized world economy, and its importance has increased as global supply chains have become more geographically dispersed, and more people have ever more people rely on it for their quality of life. Despite the size, power, and technological sophistication of modern vessels and ports, they are still impacted by extreme weather, which will likely increase in frequency and intensity due to climate change. Understanding these impacts is important for developing the necessary policies and regulations needed to create a more resilient shipping network. Historically, it has been difficult to gather the necessary vessel tracking and weather data needed for this endeavour. However, the proliferation of automatic identification systems, or AISs, and accurate weather data available through weather APIs have made it much more feasible. It is within this context that this investigation aims to assess the influence of extreme weather on the spatial distribution and operational characteristics of the North Sea shipping network using AIS and weather API data. The aim is addressed through three research questions that assess how extreme weather impacts shipping and port activity within the North Sea, how extreme weather impacts the spatial distribution of vessel traffic within the North Sea, and how extreme weather impacts the network characteristics of the North Sea shipping network. The methodology used to address these questions are summarized in the flow diagram shown in Figure 1. The main set of data is composed of about 500 million AIS records ingested from between February and to April 2020. An AIS system is composed of devices fitted onto a vessel that are on vessels that are over 300 gross tons that periodically transmit a radio message to surrounding receivers. As seen in Figure 2, the message is composed of dynamic information from about the vessel's current behavior, static information about the vessel itself, and the journey information about the vessel's specific journey. The AIS data is pre-processed to remove erroneous values, downsampled to a workable size, and filtered to only include cargo or tanker vessels. The AIS data is then divided into 3-day periods and sampled into calm or extreme weather conditions using a criteria of wind speed, wave height, and precipitation levels from the weather API data. The first research question is addressed by creating shipping statistics about the extra basin activity, port activity, and shipping activity. A geofencing approach is used, separating the study area using polygons as shown in Figure 3 down here. These are then used to classify the AIS point data by their location so they can be aggregated into statistics. The second research question is addressed by creating traffic density maps to assess the spatial distribution of differences in vessel traffic. A grid-based approach is used, converting the AIS point data into journey lines and intersecting them with a grid that is rasterized into traffic density maps. The final research question is addressed by creating network statistics for the North Sea shipping network to assess its size, complexity, connectivity, and centrality. The AIS point data is converted into a spatially representative network graph where the ports form the nodes and the routes between these ports form the edges. The difference between calm and extreme weather is then quantified using a t-test for the shipping and network statistics and a local Getis or G hotspot analysis for the traffic density maps. So the results from the analysis confirm that extreme weather causes an overall decrease in shipping activity within the North Sea. The shipping statistics show that extreme weather results in a general reduction in extra-basin activity, port activity, and shipping activity. There is also an increase in the duration of port stops and a decrease in the duration of route journeys. The shipping statistics also indicate that North Sea shipping follows a hub and spoke model. The traffic density maps show that there's an overall decrease in vessel traffic throughout most of the North Sea, but especially in the southern North Sea. However, there are some pockets of increased traffic along the coast, especially near the Netherlands. The network statistics show that extreme weather results in a general decrease in the shipping network size, complexity, and connectivity. The port and route centrality measures also support the hub and spoke model suggested by the shipping statistics. There are some important limitations and assumptions that need to be considered when interpreting the results of this investigation. One of the main assumptions made was that shipping is only influenced by weather, which is clearly not the case. There are many other potential factors that were not considered, like the day of the week, the cargo, the vessel, and port characteristics, and the influence of COVID-19. There were also some methodological limitations that could be addressed given more time to refine the processes and to thoroughly explore other potential options. Nevertheless, in terms of potential practicality, the investigation has provided an effective basin-wide insight into how extreme weather impacts the shipping activity within the North Sea, which could support the planning of mitigation measures. However, I believe the main practical potential lies in the techniques used to convert raw AIS data into useful data products that can increase its usefulness and act as a precursor to further analysis. To demonstrate this, I have developed an interactive dashboard. So it's apparent that it's much easier to interact with and interpret information in a spatially representative network graph as opposed to a raw point cloud. It's much easier to sort of explore the data. Explore the data to compare different data sets and to integrate other potential data into analysis, such as aforementioned vessel and port characteristics. Overall, it has potentially improved the usefulness of AIS data and could increase its use cases within maritime decision-making processes. Thank you for listening.
Thank you very much, Samuel.